pulleys, one 450 mm diameter and other is 200 mm. Of course we can get bigger and smaller. This is bigger, this is smaller, drawn 200 mm diameter on a parallel shaft having 1.95 meter distance apart. Of course this will be the center distance, C value, are connected by cross belt drive. Cross, very important. Cross means we need to draw the figure like this cross belt drive. If it is open you can draw. Find the length of the belt required and angle of contact between belt and each pulley. That we need to calculate. Angle, correct, alpha. What power can be transmitted by the belt when larger pulley rotates 200 revolution per minute RPM if the maximum permissible tension in the belt 1 kilonewton, correct? Maximum permissible tension, this means tension on tight side. I can write it as a T1, that is 1000 Newton, and the coefficient of friction is between belt and pulley is mu 0.25, correct? So I have written here the given data from the statement. Bigger pulley D1 here, they have considered. You can write here capital D also, this will be the small d also, and their radius they have taken. So this numerical basically from reference book, so they have used another notation, so please understand, don't confuse. This will be the diameter 200 for smaller pulley. I can take small d and radius of this small r, and distance x. See here they have taken x, we have considered c, center distance, so don't confuse. 1.95 meter, n1 is a 200 rpm, so n1 is a nothing but the bigger pulley rpm, and tension on tight side they have given, and coefficient of friction. So how to solve this numerical? First of all, read the numerical carefully, use the data as a given data and draw the diagram very carefully, correct? Then use the equation. So they are interested to calculate length as well as angle. So see, first is length of belt drive. Now they have written same equation. We are having equation of the belt drive is same as that of this. See, they have written in terms of radius. So instead of radius, how I can write the in terms of the diameter? See, L is equal to 2c plus, here they have mentioned 2x, correct, 2x. So no worry, 2c plus pi into d plus d divided by 2, here they have written this in terms of radius, plus cross belt drive, that's why again plus will be there, the d plus d bracket square divided by 4c. So same equation we need to use, no worry, don't use this equation, the familiar equation which we have seen, this cross belt, this you can use, correct, through which we'll get the length. I'll directly tell you the length is, by putting all the values, length is 1.2 plus this, it will give you 4.9 meter in terms of meter. All the terms they have taken in meter, that's why it is in meter. First part is over. Now angle need to calculate. Now for cross belt drive, we are very familiar with this cross belt drive. Sin alpha we have seen in the derivation, d1 plus d2 by c, d1 plus d2 by 2c, correct. So that value will have to add here. This is cross belt drive, so beta, so beta is sin beta, d plus d divided by 2c, this value we need to add here. Now by adding this, we will get alpha. Alpha is something 9.6 degree. So we have written for cross belt drive, it is addition pi plus 2 alpha, pi is nothing but 180, so they have add 180 plus 2 alpha, you can see here 180 plus 2 alpha, it will give 199 angle. So convert that into radian, or instead of the radian you can take pi directly instead of 180 degree, but okay, but it's okay, you can find the theta is in radian 3.477, this will be the angle. And third part they have asked about the power, so we'll move toward the power. You can see here power transmission, T1 tension on tight side, T2 tension on slack side. You can use the equation T1 by T2 is equal to e raised to mu theta, that we have seen in previous slide, or this logarithmic term also you can use, 2.3 log of T1 by T2 mu theta. Mu is known, theta is known, theta is in radian, we'll have to keep always, so we'll get the value So this value again, the tension on tight side and slack side, convert this log in this term, will get 0.378, and therefore the T1 by T2 is equal to this much ratio, correct. But they have mentioned the value of T1, tension on tight side, 1 kilonewton. So Newton is 1000. So T2 will be 419 Newton. So this will be the T2 value. As we know, power is nothing but T1 minus T2 into velocity. So same equation I have used here. So velocity is nothing but pi dn by 60. So here we'll have to take the bigger pulley. That is, bigger pulley is very important because power is transmitted through bigger pulley. Bigger pulley is having smaller RPM, correct. So bigger pulley 0.45, it is in a meter. So therefore velocity is in meter per second. Now by putting the value T1 minus T2 is equal to, the power is 2.7 kilowatt or 2738 watt. Clear friends? So check the procedure which I told you in this numerical and try to solve from your side. You will get more numerical of such type in your reference book. Please refer. Do refer. Clear? Thank you.